which of the following given statements is a rational expression? So remember, a rational expression is a fraction, and the only catch is that the top and the bottom of the fraction both need to be polynomials. So if we look at, let's see what we have here for a, look at the top, that's a polynomial. Look at the bottom, that's a polynomial. So, in fact, a is good. A is a rational expression. If we look at B, let's look at the top. As far as the top is concerned, well, 5, that's a polynomial. That is a very simple polynomial. X squared plus 2, that's a polynomial as well. So B is another rational expression. If we look at C, though, there's a little bit of a problem because we do have a fraction, but the top, tangent of x, you might remember from geometry, tangent is opposite over adjacent in a right triangle. That is a function, but it is not a polynomial. And on the bottom as well, 2 to the x plus 1, well, that definitely looks like an algebraic expression to me, but it is not a polynomial because it involves raising a power to a variable. That's not a polynomial. So C is out. And as far as D is concerned, well, on the left-hand side, let's see, 5x plus 3 over 2x minus 1, that is for sure a rational expression. 1 over x is a rational expression, but notice you have an equal sign here. So what we have in D is not an expression at all, it is an equation. So D would in fact be called a rational equation, but it is not a rational expression. And there's one other thing that I need to mention for rational expressions, and here's what it is. Take any rational expression you would like. Let's just take something like 2x plus 6 over x plus 3. So I'm just going to head off something that you might be tempted to do. You might be tempted to start canceling here. You might be tempted to cancel the 3 into the 6 because, in fact, 6 over 3 does reduce to 2. And you might be tempted to say 2x over x is also going to reduce to 2. So it seems as though this should just be, I don't know, maybe 2 plus 2, which is 4. Okay, just a question that this is going to simplify into 2. And this is going to simplify into 2 as well. But here's the other problem. This x stands for some number. And we know that if we gave a numerical value to x, we'd have to use order of operations. So, for example, suppose I said, let's let x be equal to 1. Well, on the top then, we'd have 2 times 1 plus 6, which would give us 8. And on the bottom, we'd have 1 plus 3, which would give us 4. And that, in fact, reduces to 2. Suppose we let x be equal to something. Suppose we were going to let x be equal to something like negative 5. So in our numerator, we would have, let's see, negative 10 plus 6 is negative 4. And in our denominator, we're going to have a negative 2. And that, in fact, also reduces to 2. So it certainly looks as though no matter what we plug into x, we're going to get a 2. That's kind of interesting, but we certainly don't get a 4. So just be cautious about your canceling, which is what we'll talk about in the next slide.